Hello guys, myself NSS Gaurav, presently student at Ajinkya D.Y. Patel University, collaborated with Newton School of Technology, studying at Pune. So now let us take a look of a 800 rating question in CodeForces from the contest Goodbye 2017. Question names New Year and counting cards. So let us take a look of this question. So it says your friends has n cards. You know that each card has a lowercase English letter on one side and digit on the other side. So here, according to given information, one side is of a lowercase English letter and other side is of a digit. So currently your friend has laid out the cards on a table, so only one of each card is visible. Okay, he has kept n cards, for example n cards on a table, so we can see only the one side of the card. Okay, and you would like to know if the following statement is true for cards that your friend owns. Okay, we have to check whether the condition is satisfying. The condition is, if a card has a vowel on one side, then it has an even digit on the other side. Okay, this is a condition that if a card has a vowel on one side, then it has an even digit on the other side. More specifically, a vowel is one of A, E, I, O or U, and even digit is one of 0, 2, 4, 6, 8. Here we should take a look of here 0, 2, 4, 6, 8. Okay. So what it says is, if a card is a vowel, one side is if you take a card, uh, one side is having a vowel, and if you flip the card, it must contain a digit of 0, 2, 4, 6 or 8. So this is the condition given. For remaining consonants, we need not to check. We'll look into it. For example, if a card has A on one side and 6 on the other side, then the statement is true for it. Also, the statement is true, for example, for a card with B and for a card with B and 3. So here we can see that if a card A on one side and 6 on the other side, A is a vowel, right? So it must satisfy the condition according given here, right? So it should have a digit of 6 when it is a vowel, and if it is a consonant, it can have a number or digit like 4 or 3 or any digit you can take it, because it is a consonant. The statement is false, for example, for a card with E and 5. Why is it false? It is false as E is a vowel. So E should have uh, a number of 0, 2, 4, 6 or 8. So now you are interested if the statement is true for all cards. In particular, if no card has a vowel, the statement is true. Yeah, I think you got the problem statement. Now we'll look into it into more detail. To determine this, you can flip over some cards to reveal the other side. You would like to know what is the minimum number of cards you need to flip in the worst case in order to verify that statement is true. So we should check that how many cards, like how many minimum number of cards we have to flip in the worst case to check the statement is true. How the statement will be true? By the condition given, as if card has a vowel on one side and the other side has to be an even digit. Okay, yeah, I think you got the statement. So let's once check into the inputs. Okay, see here, uh, the first and only line of input will contain string s from 1 to 50 of length, denoting the sides of the cards that you can see on the table currently. Each character of s is either lowercase English digit or a lowercase English letter or a digit. The output must be a single integer, that is the minimum number of cards you must turn over to verify your claim. So we need to find the minimum number of turns or minimum number of flips you are flipping the cards on the table. So for example, if you take here, we have an input of EE. See, E is a null, right? So it can have a digit. When we flip the card of E, we can have a digit of 4 or 3 or any even digit or a odd digit. E is a lowercase English letter, right? So if we flip it, we can have an even integer or an odd integer. So we are flipping this E one time, and it follows for the same of the second one, E. Here Z is not a vowel, it's a consonant, right? So when we are flipping Z, uh, like there's no use of flipping Z, right? So we have it can be even or odd, right? So there's no use, so the output is 0. And here checking for 0 AY1, for 0 I think it does not matter. Why it does not matter? See, 0 is neither odd nor even. Okay, so 0 can, like when we flip the card of 0, it can be an vowel or consonant. It's it can be anything, right? So A is a vowel, so we have to flip it compulsorily. Y is a consonant, we need not to flip it. We have to flip 1 because the statement does not directly mention odd digits, but we need to ensure that they do not have vowels on the other side. See, if an odd digit has a vowel on the other side, it would contradict the statement, right? So we must flip the cards which are of odd digits, 1, 3, 5, 7, 9. So why don't we flip the other cards like B, C, D, Z? These are consonants, right? So the rule only applicable for the vowels. So we are not flipping them. We are not flipping the cards which has a lowercase English letter of consonants. So now let's look into the code of it. Okay. So let me open my code. So for suppose given input like first line conversion, yes, right? See, s is equal to input. We are taking the input. Okay. Now s should be converted into a list. We have to check each and every element, right? We have to first check E, the next E, like we'll get in the third one, right? First we have to check 0, next A, next Y, next 1. So we have to check every element, right? So first we'll make it in a list, and we'll go for I in range, and we'll get all the values of S. So let's make into a list, convert it into a list. Okay. Yep. Let's see what are we getting. uh, yep, we are getting 0 AY1, this is cool. Okay. Now what is according to the question, na? If a card has a vowel on one side, then it has an even digit on the other side. Yeah, see, for I in range, no. I is, yeah, we have to use I, because we are checking each and every element, right? If we aren't checking each and every element and we are just running the code, we can even use the underscore. Okay, for I in range s, not s, it's length of s. See, the code runs for the length. Here the code is length of the input is 2, right? S is 2, here it's 1, here it's 4. See, for I in range length of s, if s we'll keep it as, name it as underscore, if s underscore of I is in any of the vowels like A, E, I, O, U, then we should add a count of 1, right? We'll take something like flip equal to 0. We'll add 1 to it. Elif if s underscore of I checking each and every, we are checking each and every element, right? So s underscore of I is alpha. No. Is digit. Yeah, like we have checked here all for the vowels, right? So if there is a vowel, we are flipping it, and if there is a digit, okay, if s of I, like s of any element is a digit, we'll check that if we'll first convert into an integer and we'll divide it by 2. So if it is see, if it is integer is dividing by 2, then we need not to check, right? See, here we have 0ay1. First I'll write the code and I'll explain. If s underscore I, yeah. Is not equal to 0, flip plus 1. Hope this code works. Yeah. Okay, see, I'll explain you the code one by one. See, here we'll visualize the code. See, 0ay1, right? Is it 0ay1? Yeah. First we have taken an input, it is converted into list, and flip value is 0. See, for I in range length of s, the length of s will be 4, right? So I starts from 0, 1, 2, 3, 4. So it will check s of s underscore of 0. S underscore of 0 is the value 0, the element is 0 as shown here. Yep. So next it will go into the list. So it is a 0, right? So the statement is false, so it went into elif condition, and in elif it is a digit, right? So it is checking whether it is divisible by 2. It is not divisible by 2, so it went for the next I, then I will become 1. Now s underscore of I, that is 1, s underscore 1 is a, it is checking for a is an AIOU, right? So we'll get the flip, it pass the condition, like it goes into the condition of if, it goes into if and flip plus 1. So here it's completed, and next I will go for 2. So next the I will go for 2 and check the I is 2 is y, right? It's a consonant, so it is not in AIOU. So it will check for elif condition. It is not there in both of them, so it will directly continue. And next we'll check for 3. 3 is 1. 1 is a digit, right? Odd digit. So first it will check in if condition, then it will go to into elif condition. In elif condition we have converted into integer, right? So 1 is divisible by 2. Sorry, 1 is not divisible by 2. So the flip value is going to be plus 1 again. So starting it's 1 and we are adding another 1 to it, so it will be 2 total. So we are getting a total value of 2. So we'll submit this code and check. Actually I have submitted, I think I have submitted this code already, so I'll once show you my submission. Yeah, I have converted it in, main point we have to convert it into a lowercase, as they have mentioned that it should be of lower English alphabet, right? So we have to convert it into a lowercase, and you can see the code here. this is the solution of the code. I hope you understood some. I'll try to improve my communication skills if possible. Thank you.